In this video, we are going to demonstrate how to properly use a pipette, especially for doing a calibration procedure. So we have two pipettes today, a 200 and a 1000, and we're going to be testing them at the low and high end of their range. So we're going to start with the low end of our 200, so that means going down to 20, and you never want to go below what is the acceptable range for your pipette because you run the risk of messing them up permanently. And then the instructors will be mad at you. So we're going to set it to 20, and it's good practice when you're setting your pipette to start above the volume that you want and then go down to it. So since we're starting at 200 and going down to 20, I'm good just going straight down to 20, but if I wanted to go to 200, I go a little bit above and then come back down to 200. That just makes sure that the tension that determines the volume is correct. So we're going to add a pipette. I'm also going to turn on my balances. We have two different types today. So this one goes to 3 decimal places and this one goes to 2 decimal places, which is sufficient for our needs today. So for the 20, you're going to want to use this 3 decimal place one to get the most precision, but for the other pipettes with the other volumes, the 2 decimal place analytical balance will be sufficient. So I'm going to add a weigh boat. Since I'm doing such a small volume, I'm going to use the tiny weigh boat. All right, and I have distilled water. And distilled water, 1 milliliter of distilled water should have a weight of 1 gram. So 20 microliters of distilled water should have a weight of 0.02, I believe, if I do math in my head correctly. All right, so I'm going to zero this so that we don't have the weight of the weigh boat in here. So now it says 0. And when you pipette, you want to go in vertically into your liquid. Only go into the liquid enough to get sufficient volume. You don't want to go all the way in there because you get little droplets on the outside of your pipette that can mess with things. And I went down to the first click. I pull it out vertically. And now I am going to dispense it at a 45-degree angle against this to the second click, so we blow out. And when I pulled it out, I made sure that there were no bubbles and that there weren't any droplets on the outside of the tip. If there had been droplets, I could have used a Kim wipe to wipe the tip without touching the Kim wipe to the very tip, because that would suck water out of the tip. So this says 0.02, so woohoo. And I'll record that volume and do another replicate after I zero. You always want to go straight in and then dispense at an angle. And that one is 0.022. So, and it's okay for there to be a little variation because these are not 100% precise. All right, so now I'm going to tare it and I'm going to move up to the higher volume. And one thing, whenever you're done with a pipette, before you put it away for the day, you want to put it back up to the high end of its range because the tension at the low end can mess with the calibration of the pipette. So I always want to make sure that we're storing them at the high end of their range. So now I'm going to go in vertically, suck up the liquid, examine it to make sure there's no bubbles, there's no liquid on the outside of the tip, and then dispense at a 45-degree angle to the second stop. And then record my volume, which is dead on at 200. So I must be really good at pipetting, and this pipette must be calibrated, so that's fantastic. Go. All right, now I'm going to demonstrate the balance a little better so you can see. This is the one that goes to 3 decimal places, the Aculab Sartorius group. Turn it on. Thinks about its life, decides if it wants to work, it does. Place our weigh boat and 0. Then I have my pipette set to 200. Through the magic of movie making, we've now got water that you can see. So and then we will record record this. This isn't going to be 100% accurate because we've added dye to it, but, and then zero it. You can see that we have these little balance wedges over here. That indicates that it's tared. You see them come, and then at that point it's stable. You can record your value and press tear again. All right, so now I'm going to demonstrate the P1000 pipette. So we're going to test it at the low and high end. Right now it's set at 1000. So I'm going to move it down to 100. And it's always good practice to store these at the high end of their range so that tension isn't held onto the springs that are inside of it. So I set to 100 and I've added a tip. I'm going to tear my analytical balance with the weigh boat on it. You want to make sure this is set to grams because that would be awkward otherwise. And go down to the first click, enter vertically, pull out, check for bubbles and liquid, and dispense. And that is 0.1, so that is looking pretty good so far. And then tear and repeat. What's nice about these is that since they don't have such high precision, you don't really have to worry about the evaporation of water. With more precise analytical balances, you have to tear it really quickly, otherwise the water evaporates and it won't let you tear. So you're lucky you don't have to fight that battle. All right, so now I'm going to move this to the high end, up to 1000. Riveting, I know. All right, I'm at 1000. Now I'm going to enter vertically. You can see there's much more push available on this lever compared to the 100. This is one reason why you want to do, when you're pipetting, to choose the pipette that allows you to be at the higher end of that pipette, because you get better accuracy and precision at the higher end of each pipette. And that was 0.99, so super close to that goal of 1 gram. And then tear and repeat. And every time you take out a liquid, you examine for bubbles and liquid at the outside of the pipette. And you do this 5 times for each pipette at each volume. And then dispense of your tips into the biohazard and calculate the mean and finish up the rest of the lap. For our next balance, you turn it on, it does a countdown, or count up. We'll place the weigh boat, tear it, ensure that it's on grams. See that this goes to 2 decimal places, and then we will pipette. And a little symbol comes up that it's steady. Record your value, tear again, and repeat. And that's how you use the balances. All right, so if your pipette failed for accuracy, your mean didn't match the acceptable range for your pipette, what you can do is you can actually calibrate it, or you can ask an instructor to calibrate it for you. Depending on the type of pipette you have, changes how you will calibrate it. So for these Edvotechs that have the little twisty dial up here at the top, these are actually kind of cool. This pops open. Don't lose it. And then there's a little red button. There's a little red button down here, and you would actually pull this back and then set your dial to what the volume was that you actually measured by twisting this, and then you would put it back. And there are detailed instructions for these in the manual for these pipettes, and you can ask an instructor for help. and then you would put it back together and then confirm that it is now accurate when you set it to your desired volume by measuring the weight of water again. For these pipettes, this is more of the standard way that most pipettes are, at least in my experience, is you kind of have to do a guess and check method where you use this key, you slot it in here, it has these little grooves, slide it in here and then turn it. I'm not actually going to turn it because this is nicely calibrated, but you go clockwise to increase the volume and counterclockwise to decrease the volume, and then you would check the volume again and make adjustments as needed. It's a little time consuming to do this, but sometimes it's necessary.